All right, let's begin our experiment. In this experiment, we're trying to see the reactivity of these three metals. The first one being lithium. Then we're gonna test sodium. And then lastly, we're gonna test potassium. So as they sit on the periodic table, we expect that this reactivity of lithium is much slower and much more less volatile. Sodium gets a little bit more reactive and like fizzes out quickly. And then lastly, potassium should show a really high reactivity. So what are we reacting it with? We're reacting it with water. So I'm gonna pour water in 3 beakers. The amount of water is not really that important for this experiment. And we're gonna try and keep the amount of each of these solids that I'm gonna put in. So this is our alkali metals. I'm gonna start with lithium. I'm gonna use a spoon. We're gonna just take a little bit of lithium in there. Not a lot, just a little. It's a very white, stony substance. Let's put that into the beaker. So it's reacting, but it's very slow. It might take the whole day to actually react. This is lithium. This is lithium. Okay. So we put in a stone there, but it shows like it's reacting, but it's very slow. And you can see the reaction take place because of the presence of this bubbles that are going up there. This shows that the reaction is taking place, and these bubbles are indicating the nitrogen that is actually being dispersed out of the solution. So that's clearly very slow. I was expecting something better. So let's go on to sodium. Sodium, on the other hand, is dispersed, or rather it's in a solution of oil to actually make sure it does not react with air, because these substances do react with air as well. So let's see how this is gonna go. Just gonna grab one chunk of sodium in there. Again, you can observe it. It's a very white substance. It's a little bit oily right now because it just comes from oil. Let's drop it in. So that is definitely more reactive. Some fire. This is cool actually. Yeah, I needed to be careful there. So that's sodium. Quite interesting, actually. We still have lithium still reacting, and sodium has completely reacted. The explosions that you were seeing is the hydrogen, actually. That's the hydrogen being repelled from the solution, and because of its really high reactivity, it makes those sparking and those explosive sounds. So potassium is gonna be even much worse than this. So let's see how that goes. We're gonna try and put a little of potassium there. It might even break our beaker. Let's just hope it doesn't. So this next one is potassium. Let's make sure we take a little bit of the potassium and not a lot. Yeah, I'm just gonna take a very small chunk. And if you observe, This is a very grayish color. And so let's drop it in. 5, 4, 3, 2, go. And that was it. So yeah, definitely you can see from right to left how significant these reactivity is. And yeah, it literally is just, the whole experiment was just to show you that as you go down the periods, the reactivity of these elements increases. And a lot of things can explain that, but another thing that is a very good way of explaining it is because of the energy levels and the shells that it has. So lithium has only 2 orbitals there, right? And in the second one, that's where you have the 1 electron. So it's a bit harder to remove that electron. On the other hand, sodium has 3 orbitals, and in the third one, that's where you get your 1 lone pair electron that sits there. And as a result, sodium is more reactive compared to this guy because it's bigger in terms of its electron. If you're just looking at its atomic level, it's much bigger because of the presence of another energy level. And so that electron can be easily taken away from it. And so that's why it reacts very rapidly. And then on the other end of the spectrum, which is going to be potassium has 3 energy level, or 4 energy levels. Yes, 4 energy levels, and it has 1 electron in the last energy level. And so as a result, it reacts much less compared to the rest of it. So that's it from my side. I hope that made sense. Thank you.